All right, so this is activity 3.4, pool level. The graph shows the water level of a pool. The x-axis represents time in hours. So time is going along this x-axis right here. And the y-axis, going this way, represents the water level. Okay, in inches. Okay. The origin, remember the origin is always 0, 0 right there, represents 3 p.m. Okay. And the desired water level. So you want the water level to be at a certain level. And so this is saying if it is at that level, if it's above it, it's higher than what you want it to be. If it's below it, it's below where you want it to be. Okay. So number 1 says label the graph with the independent and dependent quantities and their units. Well, in this one, almost always along the x-axis is the independent variable, and that is the independent variable. And that's going to be time. Okay. And then the dependent variable, which is almost always on the y-axis, is water level. I think I might have said that wrong. Let me try that again. The independent variable, which is time, is on the x-axis, and it normally is on the x-axis. The dependent variable is the water level, and that's almost always on the y-axis. Okay. This is just like in science. So the independent is kind of what's been chosen, and then the dependent depends on the independent variable. Okay. And the dependent variable is what we're measuring. Okay. Create a table of values for the points plotted and describe the meaning of each. All right. Well, if I look right here, this first point right here is -9. And then -6. Okay. And so if this is 3 p.m., 2 p.m., 1 p.m., noon, 11, 10, 9, 8, 7, 6, it would be 6 a.m. So at 6 a.m., the water level was 6 inches below the desired fill line. Okay. And so we're going to do that with all of the rest of these points here. So if I take a look, my next one is going to be right here. And so that's negative, not 4, not 5, so -4.5. And then it is 1, 2, 3, -3. And so let's see here, 3 o'clock, 2, 1, noon, 11, 10, 10:30. So at 10:30 a.m., the water level was 3 inches below the desired fill line. Okay. And so now we continue going, and the next dot along there is that origin right there. So it's going to be 0, 0. And so at 3 p.m., the water level was at the desired fill line. Okay. So like let's say like in the summertime or something, the previous day people are splashing around, and then overnight you wake up and then it's really low, and then you start adding water, you turn the water on and it slowly fills. And so we get to there, and then maybe we forget about it for a while. And so the next point on our thing is 6 and 4. Oops, sorry. 6, 4. Okay. And at that point, let's see here, 3, 4, 5, 6, 7, 8, 9 p.m. At 9 p.m., the water level was 4 inches above the desired fill line. Okay. Then we have this last one right here, and this last one was at 9, 6. So let's see here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At 12 a.m., the water level was 6 inches above the desired fill line. So if I'm trying to make a story that goes with this, and maybe I'm going to have to soon, maybe they turned the water on because it was low, and then they forgot about it the whole day, and then by midnight, it was 6 inches above where they wanted it to be. Okay. Again, we're using graphs in different situations, graphs, and being able to interpret them and be able to see what's going on in a situation. All right. So the first question now, or the question that comes next, is at what rate did the water go into the pool? Explain your reasoning. So if I'm looking at this, I can kind of see that every hour, let's see here. So if I look at this, I'm looking for a point in the line. So if I start the origin, I see that this is a point clearly on the line. Okay. And so from there, I can see that in 3 hours, the water went up by 2 inches. All right. And so it went up 2 inches every 3 hours. Now, the way that's written like a ratio. So I could actually write it 2 inches for 3 hours. And I could almost think of this as it went up 2/3 of an inch every hour. Okay. 4, describe a situation that would match the graph. Oh, good. I was talking about this as I went. Okay. In the morning, someone started filling the pool with water, but they forgot about it. Okay. The next one is write an equation for this situation, and that's really tough. But if I was to think about this, if I took 2/3 of an inch times however many hours the water was on, that would equal how much total water has been put into the pool. And this is a super tough thing to do, okay? But I can take a graph, and this is a linear graph. That means it's a straight line. Um, and I can make it into an equation to solve any problem, okay? Why does the graph stop rather than continue infinitely? Okay. maybe the pool was completely full at that time. And so all the water that was added after that was like spilling out of the pool. Okay. Using any of your mathematical tools, determine the time when the pool was 3 inches above the desired fill level. Is your answer exact or approximate? Okay. So I'm going to use the graph here. And so 3 is right about here. And so when I got to 3, so it's 3 inches above, then I go straight down. It was at, what does it say what time? The time. So 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 7:30 p.m. At 7:30 p.m. I should say about. Okay. And it's approximate. Oops. Approximate because I used the graph. And it looks like it's 7:30, but it looks like it's 7:30, but could be closer to 8. It could be 7:45. And so the graph is helpful, but it's not exact. Okay. If I had tried to use the equation, it probably could have made it so it was exact. Okay. So activity 3.4 is just another practice in using a graph in a real life situation and using a graph that deals with all four quadrants. And that was activity 3.4.